Hello everyone! Are you curious about how communication between Mars and Earth would work? Let's explore! The dream of sending humans to Mars carries with it a fundamental challenge: the sheer distance. Mars and Earth are celestial dance partners, their orbits sometimes bringing them as close as 54.6 million kilometers and other times pushing them as far apart as 401 million kilometers. This vast and ever-changing distance creates a unique communication hurdle unlike anything we face on Earth. One of the most significant effects of this distance is a signal delay. Radio waves, which travel at the speed of light, are the foundation of our current long-distance communication. However, even at that incredible speed, signals traveling between Earth and Mars encounter a substantial time lag. Depending on the planet's positions, this delay can range from roughly 3 minutes when they're at their closest, to a staggering 22 minutes when they're at their farthest. Imagine trying to hold a conversation with someone when each message takes 3 to 22 minutes to reach them, and then the same delay applies to their response. Real-time conversations as we know them become impossible. Video calls filled with awkward pauses and long waits would replace the instantaneous flow of information we take for granted on Earth. Even a simple text message would turn into an exercise in patience. Beyond the time delay, the strength of a signal weakens the further it travels. Engineers must carefully design equipment powerful enough to transmit signals clearly across the vastness of space. They need to ensure that these transmissions can be distinguished from the background noise of the universe. Furthermore, our active sun isn't a silent bystander in this communication endeavor. The sun emits a constant stream of charged particles known as the solar wind, and periodically releases bursts of radiation in solar flares. This solar activity can disrupt and interfere with radio signals, potentially scrambling messages or even temporarily cutting off communication during particularly intense events. In light of these challenges, how would Mars colonists stay connected to their home planet? The solution lies in a multifaceted communication network, leveraging a mix of strategies and technologies. To start, powerful Earth-based transmitters, like those within NASA's Deep Space Network, would be crucial for sending strong, targeted signals toward Mars. These specialized dishes are capable of amplifying messages and focusing the transmissions to maintain signal strength across the enormous distances involved. Additionally, a fleet of orbiters would likely be stationed around Mars itself, acting as communication hubs. These orbiters would receive signals from Earth and retransmit them to the Martian surface, and vice versa, helping to circumvent potential line-of-sight issues caused by the planet's rotation and ensuring messages always find a path. On the Martian surface, colonists would need receiving and transmitting stations, likely equipped with sizable antennas. These would be vital for picking up faint signals from Earth, sending messages back into space, and relaying information to and from explorers working in the field or traveling further away from the main colony. While radio waves currently form the mainstay of space communication, lasers hold exciting potential for the future. Laser communication systems can transmit data at much higher speeds compared to radio waves, offering the possibility of sending more information in the same amount of time. However, aiming lasers with extreme precision over such vast distances presents a new set of technological hurdles to overcome. The nature of messages exchanged between Earth and Mars would also evolve to adapt to the inherent limitations of the system. Voice calls would likely be replaced with pre-recorded voice and video messages, allowing people to see and hear their loved ones even if real-time conversation isn't feasible. Text-based communications, perhaps enhanced with images or short video clips, would become commonplace for regular updates and information exchange. Pressing news, scientific discoveries, or emergency updates might warrant priority transmission, with mission controllers carefully managing the limited bandwidth to ensure the most vital information reaches its destination as swiftly as possible. The psychological impact of delayed communication cannot be underestimated. Mars colonists would need to adapt to an asynchronous form of interaction with everyone back on Earth. The immediacy of human connection that we often take for granted would be replaced with a slower, more deliberate rhythm, an exchange of messages flowing back and forth across the days or even weeks. Maintaining morale and a sense of connection across this divide would require careful planning and support systems for the pioneering astronauts. However, the challenges of communication between Earth and Mars also hold the seeds of innovation. The need to transmit large amounts of data efficiently might drive advancements in data compression techniques. Engineers could develop clever ways to package information tightly, squeezing more into each transmission. Error correction protocols would become even more sophisticated, ensuring that even partially garbled messages could be reconstructed with high accuracy. Necessity might even lead us to re-envision the internet itself. Could a kind of interplanetary internet protocol be developed, designed to work over huge distances and delays? Think of a system where information is stored and replicated across multiple points on both Earth and Mars, allowing for localized access and reducing the wait times when someone on Mars wants to access news or research materials. The unique communications landscape between Earth and Mars raises profound questions about the nature of human interaction across vast distances. How would our sense of shared culture evolve when trends, news, and viral moments spread at different speeds between the planets? Could new forms of art, music, and storytelling emerge, inspired by the constraints and expressive possibilities of delayed communication? Establishing reliable communication between Earth and Mars isn't merely about logistics, it's an essential step in making humanity a multiplanetary species. The solutions we develop have the potential to revolutionize how we communicate not only in space, but also in remote and underserved regions here on our own planet. The dream of humans walking on Mars carries with it the promise of expanding not just our physical horizons, but the boundaries of how we connect across the void. Thank you for watching. Please follow for more related videos and see you later. Goodbye.